Hi there, we're going to look at Unit 4, Topic 2, Set Fundamentals. We're going to briefly go over some of the definitions just to make sure we're clear, and then we're just going to go through a few examples. So let's see here. All right. So just looking here, this is the PDF notes from the module. So it is natural to classify items into groups or sets and consider how those sets overlap with each other. Sets can be used to understand relationships between groups and to analyze survey data. The whole idea of sets is just literally to put into the right terminology a group of numbers or letters or something along those lines. So here's a couple of definitions. A set is a collection of distinct objects. These objects are called elements. Distinct means the elements do not repeat. One example you'll see when we go through them is when you have a word with repeating letters. If you were to use a set of those letters, you make sure that the set only includes the letter once and not the repeated times. Examples of these sets are the set of the first 10 prime numbers, for example, the set of all even numbers. These would all be sets of non-repeating numbers. When listing the elements of the set, we enclose them in squiggly brackets. Let me just show you what that looks like. The squiggly brackets that we're talking about are, oops, in theory, I'd be doing a squiggly. Here we go. Like that. That's what they call squiggly brackets. This is referred to as the roster method. Element, oops, and then let's go down here. So examples would be, for example, here we have 1, 3, 9, and 12. You see the squiggly brackets. That means that's the set containing the numbers 1, 3, 9, and 12. Example 2, we have red, orange, yellow, green, blue, indigo, purple. Again, that's the set containing those colors, those words. Notice, though, that there's no repeating numbers or words. Note, a set simply specifies the content. Order is not important. For example, the set 1, 2, 3 is the same as set 3, 1, 2, which is also the same as the set 3, 2, 1. Since the elements 1, 2, and 3, 1, 2, 3 are in both sets. That's important to remember. A set is equal if it contains the same elements. And we'll talk a little bit about equivalent sets also. All right, let's see. There was one of the other thing I really want to talk about was notation. So here we have a few things that are really important. This N here, that represents counting numbers starting with 1. So if you see N, it means 1, 2, 3, 4, all the way up until it's uncountable. W is for whole numbers, Z is for all whole numbers, and they're opposites. Remember, the opposite is the negative. So if you have -1, the opposite is 1. If you have +5, the opposite is -5. So Z includes all of the numbers and their opposites. That means it does not include 0. It should just be 1, 2, 3, 4 and up, and -1, 2, 3, -1, -2, -3, and down. Q represents rational numbers. That's any number that can be written as a fraction or like basically 0.5 because it can be written as 1/2 or -11/14. These are all examples. Irrational numbers is represented by I. That's something like, well, I like the square root of -1, but that's a different thing. Let me think. Pi is an irrational number because it's a decimal that goes on forever and cannot be written as a fraction. R represents all the real numbers. Let's see what else we've got here. I think that's it to go through. Here's a little bit of set notation really quick, and this is important for the homework as well. Here the this symbol represents, oops, sorry, this is not the most, an element of, and this is important when writing set builder notation. I'll fill that in, set builder notation. Element of is really important. So here we see set builder describes sets with elements that share a common characteristic or follows a certain condition. So your general form we have here, you have variable or expression, and then a line, and then characteristic or condition. where that line means such that or given that. I used to always hear given that was what a lot of my professors used. So you'll hear both though. So here's some examples. We have C equals X, given that X is an element of Z. Remember Z was all the, let's remind ourselves, was that all the real numbers, all the, right here. So just in case you forget, you can always come back. It's all the whole numbers and their opposites. So what we're saying here is that X is any number that's part of the whole numbers or its opposites. So that means that 1/2 would not be included in this set. So we would read it as C is the set of all X such that X is an integer. Then we have X as an element of the reals between, given that, or such that, -4, X is between -4 and 4, non-inclusive. Notice -4 and 4 are not included. So it's the set of all real numbers between -4 and 4. So that would include decimal zones because it's not limiting it to integers. All right, so let's go ahead and take a quick look at some of the homework problems as examples. Oops, let's see if, there we go. All right, so let's see. We've got this first one here. So which of the following is the set n of all the natural numbers between 2 and 8? Notice it said between 2 and 8. It did not include 2 and 8, and that's what we just saw with the -4 and 4. So we need to eliminate anything that includes 2 and 8, so such that we have here 8, 6, 4, 2. We know that's not it. We have up here 0, 1. We already know that's not it because 0 and 1 are less than 2, so we know that's not included. So it's either going to be this one or this one. 1, 3, 5, and 7, that's leaving some out, right? What about 4 and 6? So that leaves this one, n. That means that that set n is equal to 7, 6, 5, 4, 3. That tells us that all the natural numbers between 2 and 8. All right? That's the first example. Let's look through the second example. Here we have, and you'll notice I'm not actually able to check the answers. I had to take screenshots. It wouldn't let me walk through and pick out examples. So I just screenshotted several different examples that cover the different types of problems you guys will be seeing. So please forgive that I can't actually mark on there very easily. So here we have which set is equal to the set F. Remember, when a set is equal to another set, it means that they have the same elements, but not necessarily in the same order. That's the 1, 2, 3, and 3, 2, 1 are both equal, but they're not in the same order. So we just need to make sure we find the set that is has all the same elements. So here we have, I'm going to read them off in order because it helps me a little bit. 1, 4, 44, 808, 964. Well, and then we have 800 in there. I forgot that. So let's take a quick look. This first one, I already see that it does not include 4. So we know A is not the answer. Let's look at B, the set B here. We have 4 and 1, which is a good start, but we don't have 44, and it looks like 4 repeated itself. So B is not the right set. Let's look at C. I noticed right off the bat that 4 is not included here, so it's not the right one. So D is the answer here. We have 44, 1, 800, 808, 2,187, 964, and 4. So it includes all the same elements. So the answer here would be D. Okay. All right, that's example 2. Let's look at example 3. Here we have which of the following is the set F of the factors of 6. Remember the factors of 6. The factors are what multiply to make a number. So if we have 6, some factors would be 1, 2, 3, and 6. Because remember, 4 does not multiply into 6. 0 obviously doesn't multiply into 6. So, and nothing above 6 would multiply into it because we're only looking for factors, which would be whole numbers. So that means we're looking here for anything that includes 1, 2, 3, and 6. Obviously, this is not it. This is there to confuse you because those are multiples of 6. This is some of it, so that'd be like a subset. That's not what we're looking for either. Here we have all the numbers, but notice 4 and 5 are there, but those are not multiples, so that means that this last one right down here is our answer. F is equal to the set with 1, 2, 3, and 6. Those are all the factors of 6. All right, that's the third example. Let's look at number 4 that I picked out. Here we have, are the two sets equivalent? Remember, equivalent sets do not have the same elements. They have the same number of elements. So in this one, we have 1, 2, 3, 4, 5 elements in set Q. 1, 2, 3, 4, 5, and set W. That means that yes, these two sets are equivalent. They are not equal, they are equivalent. All right. Let's look at example 5. If it comes up, there we go. All right, use set builder notation to express the set of squares of integers between 1 and 1,000 exclusively. So there it's actually telling us do not include 1 and 1,000. So that's kind of handy. So it's not implied, it's outright said. All right, so we are looking at the squares and we're looking at set builder notation. So let's go ahead and let's see if I can make this a little smaller to see both together. There we go. All right, so we have some options here. We already know that n cubed is not what we want. We're looking for n squared. So we already know we're starting with a squiggly bracket to notate the set. And we're saying n squared such that n is an element. So we already know that. And it says integers. So we're looking at z, right? The integers. And we're saying between 1 and 1,000 exclusively. So again, we do not want that 1 and 1,000 to be in there. So we're going to say 1 less than n less than 1,000. And that's a horrible squiggly. There we go. That's better. Now, I bet a few of you are wondering why we don't have n squared here, because we're not squaring n squared. We're squaring n. We're looking at the set of integers between 1 and 1,000, and then we're squaring them. Okay, so if we were to actually start writing out this set, we don't start with 1, right? We start with 2. So 2 squared is 4, 3 squared is 9, 4 squared is 16. So we would keep going until we got to 999. I'm not going to do the math out, but 999 squared. That would be your set. So this is the set builder notation, and this is listing out the elements, okay? All right, so our correct answer, what letter would that be then? That would be, what's that one? That's going to be n squared, this part C right here. That would be the correct answer then. All right, let's look at example 6. Just 2 more, so let's go through these so you guys just can get a better idea of what you're looking at. All right, find the cardinal number of the set. The cardinal number is how many elements are in that set. So let's take a look at this one. Let's see if I can make these both show up. There we go. So we have the set C equal to x such that x is between 25 and 40. And it says also that x is an element of the integers, which is important because it means that it's not all of those numbers, it's the integers in there. Okay, so let's go ahead and list them off. We have 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 30. I know this is tedious. You don't have to write all this out. I'm just doing this to make sure everybody understands what's included in this set. 39. So what do we have there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the cardinal number of this set is 14. That means that there's 14 elements in that set. All right, we have one more here. All right, what is I want to go through this one specifically because of the repeating thing. So what is the cardinal number of the set S equals all letters contained within the word balladeer? All right, now this is kind of confusing because if you were just to count the letters 1, 2, 3, 4, 5, 6, 7, 8, 9, you would have the cardinal number of 9, but that's not right because we have some repeating letters. So what this set really has, let's look at the unique set letters. We have B, A, L. Now we repeat L, so we don't use that. We repeat A, we don't use that. D, E, we don't use that E the second time, and then R. Sorry, I'm having a hard time writing that squiggly bracket. All right, so we have 1, 2, 3, 4, 5, 6. So the cardinal number for this set is 6. All right, so I think that covers a lot of